In this video, we're going to do a proof of the utility maximizing condition. We're going to start with a generalized Cobb-Douglas utility function, where x and y represent units of good x and good y. The consumer's budget constraint, M, is income, money income, and we have the price of good x here, P subscript x, and the price of good y, P subscript y. Just to note here that the marginal utility of good x is going to be given by this partial derivative, taking the partial derivative of the utility function with respect to x. And the marginal utility of good y will be another partial derivative of the utility function with respect to good y. We get back this result. All right, so we're going to do a proof of the utility maximizing condition. I'm going to set up a Lagrangian. So I am going to plug in the utility function here, this generalized Cobb-Douglas utility function, and then plus lambda, and in parentheses here, this lambda is being multiplied by the budget constraint. We're going to take three partial derivatives. We're going to take the partial derivative of the Lagrangian with respect to good x, set that partial derivative equal to 0. We get this result. We do a similar partial derivative, but this time with respect to good y, and we get back this result. And one more partial derivative of the Lagrangian with respect to lambda, and we get back the constraint. And again, all these partial derivatives are set equal to 0. Moving on, I am going to take this first result here, this first partial derivative, and I want to solve it for lambda. So taking lambda multiplied by the price of good x and moving that over to the right-hand side, we have this result. And then I'll recognize that the left-hand side, this left-hand side, is just a marginal utility of good x. So making a substitution, this left-hand side is just a marginal utility of good x. We now have this result. And dividing through by the price of good x, lambda equals a marginal utility of good x divided by the price of good x. Moving on, taking this middle result here, this second partial derivative, I'm going to do a similar thing. I want to solve it for lambda. So moving lambda times the price of good y over to the right-hand side. And now recognizing that the left-hand side is just a marginal utility of good y. So what we have here on the left-hand side is just a marginal utility of good y. I'll make that substitution. And I'll divide through by the price of good y. So we get this result. I'm going to set both of these lambdas equal to each other. So setting lambda equal to lambda. We have our utility maximizing condition, that the consumer allocates his or her budget in such a fashion that the marginal utility per dollar of good x, this left-hand side term, this marginal utility per dollar of good x, equals a marginal utility per dollar of good y. If we want, we can rearrange it and just dividing through by the marginal utility of good y and multiplying through by the price of good x. We could rearrange it like this here. So the ratio of the marginal utilities equals the ratio of the prices. You might recognize here that this left-hand side would just be the marginal rate of substitution. Okay, that's it. I hope you found this video helpful.